Do you know why metals conduct electricity, can be bent into shapes without breaking, why they're shiny, and why they're usually strong? That's something called metallic bonding. First, let's start with the basics. Metallic bonding happens only between metal atoms, like copper, iron, aluminium. You name it. It's different from ionic bonding, which is between metals and non-metals, and covalent bonding, which is usually between non-metals. So, how does metallic bonding actually work?
Imagine a whole bunch of metal atoms coming together to form a solid piece of metal. Each metal atom has 1, 2, or sometimes 3 electrons in its outer shell. These are called valence electrons. Here's the key part. In metals, those outer electrons are only weakly held by the nucleus. When lots of metal atoms get close together, those valence electrons don't stay stuck to just one atom anymore. Instead, they break free and start moving around between all the atoms. We call this a sea of delocalized electrons, or sometimes an electron sea. The electrons are delocalized, meaning they are not tied to any single atom. They belong to the whole metal structure. Now, when an electron leaves its original atom, that atom becomes a positively charged ion. So you end up with a regular lattice, like a 3D grid, positive metal ions sitting in fixed positions. These positive ions are then strongly attracted to all the negative electrons swimming around them in that sea. It's like the positive ions are glued together by a shared cloud of moving electrons. Metallic bonding explains almost all the weird and useful properties of metals.
Firstly, metals are good conductors of electricity, as the free electrons help carry on electrical charges, making them optimal material for electrical wiring. Similarly, the free electrons also help rapidly carry and transfer kinetic energy throughout the material, allowing metals to transfer heat, making them a good material for producing cookware. Furthermore, metals have strong electrostatic force of attraction between metal cations and CFT localized valence electrons, which makes it difficult to overcome, requiring a lot of energy, therefore also making a good material for producing cookware. Metals are shiny and lustrous, reflecting light really well. This is because the free electrons can vibrate and re-emit light waves. Lastly, let's see what happens when we apply force to this metal. The atoms, arranged in layers, slide over one another without breaking their metallic bonds. So, why is that? It's sea of delocalized valence electrons surround these positive metal ions, acting as a flexible glue that allows the atoms to rearrange under stress, making metals ductile and malleable.